Let's finish off this lecture with two more versions of this problem. In this version, you're asked to figure out the probability that at least one ball that you draw, one from each arm, is either red or yellow. So you draw two balls, at least one of them is red or yellow. So you start thinking about all the different ways that could happen. Well, you could draw red on the first, and then any color ball on the second, and that would give you a favorable one. Or you could draw a red on the second and any color ball on the first, and that would give you a favorable one. You could draw a yellow and any colored ball, but you have to make sure you're not repeating cases. Oh, this looks really complicated. You might think, how am I ever going to solve this? Well, if you're careful and figure out every possibility, you can still solve it that way. But when things start to get complicated, one thing you might want to consider is, what about the negation rule? So I'm trying to figure out the probability that I get this. The probability that I draw two balls is 1. The probability that neither is red or yellow, that's the probability of not getting this event. So 1 minus not getting this event equals the probability of getting this event. So I say, okay, well, how do I not get this event? Well, if I draw green on the first, then that's not a red or a yellow ball. And if I draw green on the second, that's not a red or a yellow ball. So this is the only way for this sequence of two draws to yield an outcome that doesn't have at least one ball that's red or yellow. So now I need to use the negation rule here and subtract this conjunction from 1 to get my answer. So I plug my numbers in, again using the classical interpretation. The negation rule tells me the probability of getting at least one ball from my two draws that is either red or yellow is going to equal 1 minus the probability of getting a green on the first, 3/9, times the probability of getting a green on the second, 2/9, or 1 minus 6/81, which equals 75/81. So again, you can see when a problem starts to get complicated, it's at least worthwhile to check and see, hey, maybe I can use that negation rule. Is computing the probability that this event doesn't happen easier than computing the probability of all the different ways that it could happen? And in this case, it definitely pays off. We'll have one last version of this problem to end our lecture with. Suppose I want to compute the probability that I draw a ball from each urn and both of those balls are the same color. So now I think about this and I go, okay, well, if I draw a red on the first and a red on the second, they're both the same color. That's a favorable outcome. Or if I drew a yellow on the first and a yellow on the second, that's a favorable outcome. Both are the same color. Or if I drew a green on the first and a green on the second, then they both be the same color. So now I think there are 3 ways for me to draw two balls, one from each urn, that are the same color. So now I think about the rules I need to use here. Well, restricted conjunction for the red, restricted conjunction for the yellow, restricted conjunction for the green. Again, restricted conjunction requires they're independent, and what I draw from one urn doesn't affect what I draw from the other urn. So I'm good. I've got ors here, right? I can get it this way, or this way, or this way. So now I have to ask myself about the relationship between these, and I say, oh, are those exclusive? That is there only one way I can get it? I can't get this one and this one, and that's right. There's only one outcome of two draws. It could be this one, it could be this one, it could be this one, but it's only going to be one, and so I can use the restricted disjunction rule to get the probability of drawing two balls that are the same color. Now I just need to plug my probabilities into those formulas. So the probability of getting a red and a red plus the probability of getting a yellow and a yellow plus the probability of getting a green and a green. So red and a red, 2 over 9 times 4 over 9. Yellow and a yellow, 4 over 9 times 3 over 9. And finally, a green and a green, 3 over 9 times 2 over 9. So now I go, okay, I've got 8 over 81 plus 12 over 81 plus 6 over 81. That gives me 26 over 81 as my solution. Okay. So now we worked through a whole bunch of different problems. Some of them were easier than others. Some used restricted conjunction, some used general, some used restricted disjunction, some used general, some used negation. Right? There's another list of probability problems, another video that is, where I go through a whole bunch of probability problems. Again, you can try doing that one as well. And as always, once you get the problem, stop the video, try and solve the problem on your own, then start the video and compare and see how you did. There's also all of those practice tests and extra probability problems that have their answers worked out in the key that you can do and then check with that as well. They're not videos, but they are giving you the answer and indications of how the answer was computed.